see. And then what do we do with it? That's when we do the inferential statistics part. That's where we say, okay, I want to know something about the population. I couldn't ask everybody, so I took a sample, and I'm going to use the results of my sample to generalize to the whole population. We took a sample of Reese's Pieces, and in our sample, none of our samples, were really, very evenly distributed with the three colors that looked like we had way more orange. So we would generalize that in the entire population of Reese's Pieces in the whole wide world, that there are more orange Reese's Pieces than yellow or brown. We would take our data and maybe we'd be able to make a generalization. If we had, high schools from every state, then we could make a generalization about the whole country. Okay, but we have to just kind of go back to the whole, we're going to make that inference, make that generalization to the whole country. Now, can we make that inference for just the Ysleta district? Unfortunately, no. Okay, if we took our sample from every state in the nation, then our population, we go back to every state in the nation. If we only wanted to know something about the Ysleta district, then we would just take a sample from that district. So you've got to be careful, depending on what population you want to know something about, you want to make sure that your sample matches that. Okay, a little bit more vocabulary here. We're going to talk about a variable. We've talked about variables in all of your kind of algebra classes. It could be a number and it can change from one value to another. Usually our variables are going to be some sort of characteristic, something that we're studying. Data. We're going to throw that word around a lot. It's observations, it's information, something that we have. Maybe it's going to be on one variable, maybe it's going to be on two. It could be on more, but that's not statistics 1. That's more advanced statistics. And we want to have it, somehow we had a system for collecting it. It's not just numbers we made up. Data can come in a lot of different forms. We're primarily going to be dealing with numerical data, but not always. We could get our data from some sort of study or from an experiment, and that word data is actually plural. The singular, we would have one datum, or we have a lot of data, and so that's a little bit of trivia for you. You've probably heard something like this on a commercial, don't drink and drive, you don't want to become a statistic. Yeah, that's not really true, because the statistic is the number that we calculated. If you drink and drive and, crash and, die, you'd be a piece of data in that study, and so you'd be a datum. So just, nerd talk. What kinds of data are we going to study? Okay. First, we have categorical data. Categorical data is also referred to as qualitative data. You need to know both words. Categorical data, we're putting data into categories, or we're talking about qualities. These are things that are generally not numbers, like the color of cars or the color of Reese's Pieces. Some sort of characteristic that's not really a number. Then we have quantitative data or numerical data. Once again, you need to know both words. Quantitative, quantity, number. Okay, so any kind of data that is numbers. Now, okay, that's not actually correct, because sometimes our data are numbers, but they're not really numerical. For example, your ID number. Yes, your ID number is a number, but it's really just a classification, We wouldn't average it. We wouldn't average your zip code, okay? So even though your zip code is a number, it's really just a label. It's, oh, you live within these boundaries, okay? So be careful with that. There's a few numbers that are really qualitative data, not quantitative data. So ask yourself, okay, would I take the average of this? Would that make any sense in the whole wide world? I mean, we could average your zip codes, but it wouldn't make any sense. It wouldn't give us any information. Now, qualitative, categorical data, that's it. If it's categorical, that's it. If it's quantitative data that we're looking at, then we also have another way that we can describe it. So if it's numbers, we need to decide if it's discrete numerical or if it's continuous. Discrete is those graphs, if you remember from algebra and algebra 2 when we were doing domain and range questions, where it was just a bunch of dots. We didn't connect the dots, it was just the dots on the page. That's discrete. Usually it's just some values, counts. We're only going to have these specific numbers, okay? As opposed to continuous, which is where we kind of connect the dots. It can be anything in the middle. So usually if we're counting, it's discrete, because I could have 1 M&M, 2 M&Ms, 3 M&Ms. But if we're measuring the heights of female students, I can have someone who's, 5'3.5" inches, 5'3¼ inches. I kind of can use all those decimals in between, so I connect the dots. That's continuous data. Finally, things that you should ask yourself about data. And this is going to be something that you're going to need to kind of refer back to all year long. It's not always going to be explicitly asked in the question, but you should at least kind of be doing that on your own, just real quick in your head. Any kind of data that we have, you need to know all the questions, okay? Just like you're writing a newspaper article, you need to know the who, what, where, when, how, and why. If you want to be able to say anything useful, you must at least know who, what, and why. If you don't know who, what, and why, then who cares, really, okay? We're talking about the who. Who did we get this data from? Did we do an experiment on some people? Did we do an experiment on some plants? Who are we getting this data from? We need to know what we measured. What data did we get? What kind of variable is it? What did we actually measure? And why? What question are we trying to answer? We generally don't go around collecting data just for the fun of it. So we need to have a reason, something that we're testing, something that we're trying to figure out. We'd like to know when and where the data was collected. That helps us out. We don't want to be making decisions on data that's from, 1943, because things are a little different now than they were in 1943. And then how the data was collected. And that's going to be our first unit of study.